Now that we've gone through an overview of the system a little bit, we're going to go in a little bit deeper in how a specs-driven system works, sort of how it does its magic. First, we're going to go to our job list, and we're going to create a new job. Now, when you create a new job, you're going to bring over specifications from your standards, and you can set up as many sets of standard specifications as you want. You could have some for, maybe you have hospital specifications, or you just have your standard everyday specifications, or you have a specific customer that has a certain way that things work with them. So you can have as many specifications as you want and as many sets of specifications as you want. So once you create the new job, we're going to give it a bid ID, and I'm just going to call this Demo 1. So your bid ID a lot of times is what maybe you know that of as in your company, and your customer might know that as something else. Might be demonstration building on First Street. And then you can set your bid date, and we'll set whatever bid date we want. It's going to keep track of the rest of this for us. So let's close the job list, and then we're going to go into our takeoff items. Now we're going to start out with an empty takeoff. So since we're kind of going through how the system works and everything, we're just going to make this a simple takeoff. We're going to have to need a specification to start with, so we're going to make a chill water spec here. And everything here, we're going to say it belongs to drawing M0.1. And we're going to make this zone A. It's on the first floor. And those are the fields you have to fill in. These other fields here, customize. Well, all of these are customized. You can change the names and use them how you want. But we don't need to worry about these too much. It's not in an alternate. It's in the base bid we're looking at. And when we picked that chill water, it knew what the default was, and it set the hangers as clevis and insulation spec. So we're ready to go at this point. It's also dimmed out any items that don't work with this spec. So let's pick pipe, and we'll make this real simple, 2-inch. We're going to take off 100 feet of this pipe. And while we're at it, let's throw in, say, a 90-degree elbow, 2-inch, and we'll just throw in 5 of those. And let's go ahead and close this. Saving our changes. And now we'll be ready for the report control panel. In the report controls panel, we're going to recalculate, and we'll see how that takeoff and specification goes together and what results we get out of that. So there's no warning. That's a good thing. So let's go straight to our detailed price and labor report here. When we go to our detailed price and labor report, we're going to see all of our results here. And now thinking back to takeoff, remember what we told it. We told it we had 2-inch pipe and we had some 90-degree elbows. We didn't tell it what kind of pipe or what kind of joints or what kind of hangers or any of those kind of things. We just told it its spec was its CHW spec. So if we take a look here, it took that piece of pipe, it looked at that spec, and it said, oh, that's copper tube for that pipe, and it's going together with 95.5 solder. And so it went and looked up that pipe by the size, it got its price, and it's got its material and labor. Now down here, same thing happened with our 90-degree elbows. It went and looked them up, it figured out, oh, those are wrought copper 90-degree elbows. But it also figured out that it needed 4 couplings. 100 feet of pipe, it needed 4 couplings. And that's because of the spec as well. It also figured out that it needed clevis hangers. And if you look at the size of those clevis hangers, they're oversized for the insulation. It put some rod in there. It put in some supports to hang those hangers. We got some shields and also put in some pipe tags. And it's got all this joint information down here. So when everything is said and done, it's coming out with a total of about $2,900 and 27 hours. Now, $2,900 for our demonstration purposes is using all multipliers of 1.0. Your multipliers are going to be probably 0.5 or less. So, if you're trying to get an idea if this is ballpark correct for 100 feet of pipe, and 5 elbows, it's going to be less than half of that if you have your discount multiplier set. So let's close out of here, and let's go back and see how it really did that. What the magic of a spec-driven system is, and how it all works together. So in here, back to the takeoff. So that pipe was 2-inch pipe, 100 feet, and this is its spec. If I go right here, and I right-click, and I hit Edit, it's going to take me right into the pipe specs. There we go. So, remember it was 2-inch pipe. So this column right here is for 2-inch and down. Then this column right here is for 10-inch and down to 2-inch. And you can control all these. You could go through here and set the size break, and you could say this is good for 12-inch, whichever you want. You control it all. You can make a new size break, all that. So when you look in here, we'll take a look at our copper pipe here. Well, that's what this is. If I look at that, bring it over here, and if we take a look, it knows this kind of copper pipe, copper tube type L. Its standard length is 20 feet, and 2-inch. It's got a price, and it's got labor values. It's also got price codes to automatically update the prices with Harrison Price Update Service. And it's got a discount group out here where it goes out and you set your discount. So it's all set up. Now one thing I didn't show you there is when we go through there, we go through this screen, which shows all the things I could have had picked in there. If I wanted to, I could have up to 2-inch. I could have Silphos, copper. I could have steel. I could have PVD, whatever. It's all set up to let you do all of that. Now the next thing we had come out of here, well, let's do a little jump here. The pipe fitting joints. And again, I could have lots of different pipe fitting joint tables. But this is the one we're using right here. It's telling us we need a coupling for our joint. You can also put in consumables and some other things in there. So let's pop back out of here. So now if I go to my fitting set, in this case there's 2 fittings that we're concerned with in our fitting set. We're concerned with the 90-degree elbow that we took off, and we pop in here, and it's going to find that 2-inch, and it's going to find the price, the labor, and all the information about it. But it's also that automatic joint spec said I need a coupling for every pipe joint. So it's also going to be coming here looking at the coupling, and it's going to find the same thing here for coupling. It's going to go and find out what they cost and what they labor at. So your automatic joints are going to take care of generating the coupling, and your takeoff's already said it needs a 90-degree elbow. You're also going to get some fitting joints along with that, but with a rock copper system and a fitting joint, it really isn't a whole lot unless you set your consumables in there and you'd have a little solder and that type of thing. If we go down here a little bit more here, down, 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 our hanger spec, if you remember it was clevis hanger. I went a little too far down. And that was because it defaulted to it based on up here. So our spec we already had set up as a default for that. We could have changed it. The defaults are really nice because that means when you pick your pipe spec, everything gets set up and takeoff for you already for your most common conditions. And you don't have a case of, say you're running underground pipe in the spec, it'll default to say no hangers, so you don't accidentally get hangers in there when you don't want them. So then going back down here to our clevis, so it says okay, it's a clevis hanger. This is what we're using for clevis hangers here. And if I take a look and edit that, it's going to tell me to oversize that hanger for the installation. It's going to tell me what the spacing is. It's going to tell me what kind of rod to use. It's going to tell me what kind of supports to use, what kind of clevises to use. So if we pop in here, we're going to see we have price and labor for clevis, and we've got it all price coded, and we've got discount groups for it as well. So everything's set up and it's going to come out of there. Now to oversize, it's using its standard installation spec. So if I pop up here and edit that, it's telling me that for 2-inch we're going to use a 2-inch here. We're using 1.5-inch thick, and that's where we're getting our 5-inch size for our hangers. Now notice the insulated size here. In some cases, insulated size you could calculate just by saying, double the insulation thickness and add the pipe. But hangers actually come in some standard sizes, and this lets you apply those standard sizes more directly and control it. All of this stuff, everything on here, is entirely controllable by you, the estimator. You can come through here, you can change anything and pick different things, and it's really easy to create and modify specifications and tables, and we'll go into that next. So let's close out of here. So that kind of gives you an idea of the power of the spec-driven system. The other part of that whole power is I could go through here, switch this to something else, and I could recalculate and get completely different results. So if somebody wanted to have the same items in plastic as they had in, what's going to be if I run it with some other material? If I ran this with PVC or whatever it is, all you have to do is change it in here and run the reports again, and you're done. You don't have to go retake off anything. You can use search and replace to change a whole bunch at once. So the spec-driven nature of the system gives you a huge amount of power and makes your takeoffs faster and makes it much more usable.